Hey there, Earth Science fans. Did you guys hear that they discovered a new black hole this week? I mean, it's crazy. It's about 1,000 light years away from Earth, and it's the closest black hole that they've ever discovered to our solar system. And we're talking about the life cycle of stars today, so this is a perfect way to start off our lesson. So, what is a black hole, and how do they form? Well, black holes come from dead stars. Our sun is a star, but there's stars of all different sizes. Now, black holes come from the biggest stars. So, stars that are 20 to 40 times the size of our sun, when they die, they turn into black holes. So, here's a little background for that. Basically, inside of every star, there's a balance between two competing forces: the force of gravity, which we've learned about already, that pulls things inward, and the force of fusion, which we'll learn about later in the lesson today, which pushes outward. That's how stars create energy. So they're typically in balance, or they fluctuate a little bit, but at the end of a star's life, when it's run out of energy, if it's a huge star, it explodes in a supernova. So all that fusion pushes outwards. And after it explodes, gravity takes over. And when gravity takes over, that's how we get to black hole. Basically, black hole is the result of all of the mass in a huge star being contracted from gravity into a single point of intense density and gravity. So that's what a black hole is. Um, and if you notice from the picture here, it's kind of crazy. They actually warp, because of all of that gravity, they warp the space and light around them. So it's a dead star, it's intense gravity, intense pressure, and it warps the space around it. All right, so black holes are points of extreme gravity and pressure and density, and they come from dead stars. But how do scientists discover them? I mean, they are black holes. That means that they don't light up like stars, which are relatively kind of easy to find. So, how do scientists discover these things? Well, sometimes they look for places where there's a lot of gravity, but they don't see anything. Like in the case of this recently discovered black hole, there's three stars orbiting this area of nothingness, and the inner star that's orbiting that point is has got kind of a funky orbit. So they know there must be something with a ton of gravity right here in the middle, and the only thing that could throw a star's orbit off like that would be a black hole. Now, sometimes, like here in the upper right corner, black holes get caught actually destroying stars. Here's one that's engulfing a blue giant, and we can see that it's like there's could be a burst of energy. It could be like a gamma ray burst, which is shown down here in the bottom right. Sometimes black holes merge together, or they merge with neutron stars, and there's a gamma ray burst of energy that we can detect on Earth. So, from what we know about discovering black holes, it turns out that they're probably pretty common in our galaxy. There's believed to be a supermassive black hole in the center of our galaxy around which the whole galaxy orbits, and then possibly hundreds of millions, if not more, black holes throughout just our galaxy alone. So I definitely went on a bit of a tangent talking about black holes, but the main topic today is the life cycle of stars, of which black hole is a part of. It's right here at the end of the life cycle, a really old or dead star right at the end of its life. There's definitely a lot of great black hole content online. This is a video called Black Holes 101. I'll tell you everything that you want to know about black holes and maybe anything that I missed in my overview at the beginning. And you can respond to your Thinking Right questions below in that assignment. So, in understanding the life cycle of stars, the first thing is to understand what a star is and what makes it a star. So, a star is defined as a huge ball of gas that creates and radiates light. Remember that planets could be huge balls of gas if they're Jovian planets like Jupiter, but what makes a star unique is that it creates and radiates light. And it does so with a process called nuclear fusion. So, nuclear fusion is when stars compress two hydrogen atoms into a helium atom, which creates energy and light. And that sounds nice, but it's actually pretty crazy. So, hydrogen is the most simple atom. It has one proton in its nucleus, and it's the first on the atomic scale. Well, the pressure inside of a star is so great that the hydrogen atoms that are already there that make up the star get pushed together and smushed together to form helium, which is the second atom on the periodic table. So two of those protons together to combine to two protons in the helium nucleus. And as they smush those atoms together, or as they get smushed together in the core of a star, it releases energy. And earlier we talked about that outward fusion force. What's happening because of these nuclear reactions in the core are creating energy, which creates the light that we see that brightens up our universe, that brightens up our universe. So now that we know a star is a great ball of gas that creates light and energy with nuclear fusion, we can move on to the life cycle. And the main thing to point out here in the life cycle is that there's two major paths that a star could take once it starts its life, once it starts the fusion process and begins creating energy. There's average sized stars and massive stars. Basically, if a star is huge, it goes along this path, becomes a red supergiant, it goes supernova, and it turns into a black hole or a neutron star. But if it's just an average sized star, like our sun, it becomes a red giant at the end of its life, and then it runs out of energy. It's not as dramatic as the supernova explosion, and then it releases its gas as a nebula, and then it lives out its life as a white dwarf or like an old dying star. And moving right along here, this is kind of cute. Ayo. It compares the stage in a star's life to the stage in a human's life. We'll keep going, and that'll bring us to the first stage of a star's life, or a nebula. And nebulae are beautiful clouds of dust and gas floating in space where stars are born. Sometimes they're called stellar nurseries. Basically, yeah, they're floating clouds, and when they start to come together in the center because enough matter gets accumulated in one area, they start the process of a star forming. And it's important to also point out that nebulae come from dead stars, so it starts the life cycle over again. That's why we call it a cycle, because when a star goes supernova or it sheds its gas in some way, it creates a nebula, which can create a new solar system out of the remains of an old solar system, starting the cycle over again. All right, after nebula, we have stage 2, which is the main sequence stage. And this is the stage that stars spend most of their life in. It's called the early stage. If you were a star, you would be in the main sequence stage of your life. It's like the childhood through adulthood of a star's life. So early stage of a star's life, stars spend most of their life here, and they can spend billions of years in the main sequence. There are average-sized stars and massive stars. I think I said this already, but our star, the sun, is an average-sized star in the main sequence of its life. So all stars go through main sequence, and then this next stage is when we start to see a split. Remember, there's two paths. Massive stars go one way, and average-sized stars go another way. So if you're an average-sized star, at the end, towards the end of your life, like middle-aged, when you're starting to run out of energy, you become a red giant. And that's when the star expands, it cools off, and it turns red. Basically, it's starting to run out of energy. It's not dead yet, but it's starting to burn different things in its core. If you're a massive star, you become a red supergiant. So just a larger version of what we already talked about. It expands, cools off, and turns red as well. All right, so like I said, at this point, the star's running out of energy. It's running out of the hydrogen that fuels the nuclear fusion reactions that creates energy. So it's nearing the end of its life. So the next stage is going to be the death, or the last stage of the star's life. And if it was an average star, it turns into a white dwarf. And a white dwarf is when the star shrinks, the surface temperature increases, and basically gravity's taking over at this point. So that's why it collapses down in size. The temperature comes from the fact that now all of those atoms are closer together. So there's more friction, there's more heat in some ways on the surface, but the star is slowly cooling off, and it does so until all that's left over is the core. the solid crystal core. Now, if that's a carbon core, that would make the leftover after a white dwarf a planet-sized diamond. So there's places in the universe where there's diamonds the size of planets out there. Now, if the star was massive, it turns into a black hole or a neutron star. We talked about this, how red supergiants explode in an event called a supernova, and that creates a new nebula that can turn into a new solar system. Well, what's left gets taken over by gravity because there's no more fusion happening. So gravity takes over. It takes all that material, collapses the star down to a small point of intensely dense nature called a black hole or a neutron star. We talked a lot about black holes at the beginning, but not about neutron stars yet. Basically, a neutron star is similar to a black hole, but it's slightly less heavy and it rotates. If it doesn't have as much mass needed to turn it into a black hole, it turns into a neutron star, which is kind of spherical, like a planet or a star, and it rotates. I believe it emanates radio waves, which is how we detect them, but it's just another type of dead star. All right, just to recap what we learned today in the life cycle of a star, they all start out as nebulae, or the plural of nebula, a cloud of dust and gas. If it's an average-sized star, at the end of its life, it grows to become a red giant, a nebula, when it sheds its layer of gas, and then ends up living out its life as a white dwarf. If it's a massive star, at the end of its life, it grows to a red supergiant. It explodes in a dramatic event called a supernova, and if there's a good deal of mass, it becomes a neutron star. If there's an extreme amount of mass, it becomes a black hole. All right, Earth Science fans, that's it for me. Stay safe out there, be good, and I'll catch you next time.